Hello, my name is Andreas Zegowitz from the Fraunhofer Institute for Building Physics, IBP in Germany. Welcome to the fourth video of the fifth module where we discuss the measurement of the thermal properties. In the previous sub-modules, you have learned about the construction, the heat and moisture transport, and the energy efficiency of the construction in RANCHI. Today, we will have a look at the durability of the construction by evaluating the thermal properties of construction materials using measurements. In order to perform the analysis, you have seen in the other modules and sub-modules that a lot of material properties have to be known. Today, we will have a look at how the thermal properties of the building materials are evaluated. If you do not have the thermal properties from the producer, the only way to get them is to determine them by using measurements in the laboratory. Therefore, we will see now the typical measurement methods for the determination of the thermal building material parameters. But let us first have a look at the materials itself. Although we know the properties of monomaterials, often we have to deal with the new materials which may be composite, as you can see on example here. As mentioned, we know the parameters of individual components, but we cannot make any statement about how the materials behave in the composite. So let's have a look at this sample. A section of a reinforced concrete structure is shown here. We do have the property of the steel as well as the property of the concrete itself. But we could also measure the pure concrete and the steel bar separately. But due to the different transport mechanism within the materials, we cannot determine the properties of the composite values unless we measure the combined materials. So besides the fact that we have to measure new materials, we also have to measure composite materials in order to get their properties. But now let's have a look at how to do this and what devices we need. With the guarded hot plate apparatus, such building materials with dimensions of about 150 by 150 mm can precisely be measured the thermal conductivity. In order to do so, a sample has to be put between two plates. One side is heated and the other side is cooled. This generates a temperature gradient, forcing the energy to flow through the sample. By measuring the temperature difference above and below the sample and the energy needed to remain the temperature difference constant, the heat flow through the sample can be determined and the thermal conductivity, called lambda, can be calculated. These lambda values are later used to calculate the U values, as you have seen in the other submodules. On the picture you can see an employee of the Fraunhofer Institute for Building Physics putting a sample into the guarded hot plate device. Guarded hot plate devices come in manifold variants. They differ in the dimensions of samples and also in the temperature range and the angle in which measurements can be performed. In this picture you can see one sample device which is capable to measure composite materials. This device can also be tiled and determine the heat flows depending on the angle. Inside the device, different modules are installed. These make sure that the heat flow runs always vertical through the sample, even if the device is tilted. This is needed so that the measured heat flow gives only the heat flow through the sample. This has to be true even if the measuring is not made vertical but tilted. for example due to measurement of pitched roof components. It is necessary to exclude all heat flows not going through the sample, as out of the measured heat flows the thermal conductivity is calculated, and even small mistakes in the measurement can lead to huge difference in the resulted lambda values. So the devices themselves, but also the handling, is not easy and should be performed from specially trained personnel only. As we now have seen how to measure the thermal conductivity, let us have a look at another measuring device. We refer to it as the climate or sun simulator. With this measurement station, we can introduce particularly high irradiations on materials or components. This is used on the one side to minimize different stress situations on building components in order to find out how durable they are together with different climate conditions. On the other hand, we can also measure the heat through an opaque or transparent material entering the room behind. The device itself consists of daylight lamps, which are capable to produce the whole light spectrum of the sun, especially the UV wavelength. You can see these lamps in the left picture. On the right picture you can see a setup experiment with the second part of the device. With this second part, the energy introduced through the lamps is balanced and measured. In the picture you can see the insulated pipe going from the radiated component to the cooling device. Also for this device, different types are available, and you will see another of these climate simulators in the submodule 6.6 if you like. But now let us sum up what we have learned. With the guarded hotplate apparatus, we can measure the heat flux and calculate the thermal conductivity of components, no matter if they are mono materials or composite. With this knowledge, we are then be able to calculate the U values of constructions and evaluate the energy efficiency, for example. Also, we have seen a device called Climate and Sun Simulator, which can be used to evaluate the energy flow through a transparent or opaque component together with sun radiation from outside. This gives us the knowledge to calculate, for example, the solar radiation entering a room. Even if there are other devices for measuring the total energy transmission called G value, the reflectance and the absorption, these measured properties can also be derived from this measurement. All these measurements help us to understand more about the materials and components we are using in other buildings and help us to evaluate the future buildings even during design. But without these measurements, this is not possible. So let me sum up. Measurements are necessary before evaluating balances and before simulations can be performed. Various methods are available in order to measure the properties of materials and components, of which we just have seen 3 in this lecture. But we need this if we want a qualitative forecast through balancing as well as through simulation. So we need the thermal parameters for new materials and have to use different measurement devices to measure different materials in different sizes and directions. Thank you for your attention, and goodbye.